Today's the 24th. 224. We're going to call this harder logs. Um, Usually my lessons I can fit on one side of a note card. This one took four sides of a note card. Well, four note card sides. And so there's quite a lot going on here. So do you guys know? I just got to start going. I'm just going to roll. Make sure you write quickly and ask questions when you have them. Do you guys know what that means? What if I told you that it equaled 9? Here, I'll give you another one. Can you crack the code? So yeah, so like what's another way to write 125 to the power of 1/3? What am I doing to turn 125 into a 3? Okay, let's try an easier one. What am I doing to 81 to turn it into 9? Square rooting. Good. So what happens with our fractional exponents? This isn't worth a day. This is worth like 2 or 3 minutes of our time. Is this notation, a fractional exponent implies a root, and the flavor of the root is determined by the bottom of the fraction. So like in this case, you can see that the 2 is on the bottom. So that implies that we're going to take a second root, commonly known as a square root of 81. Okay. We don't put 2's on square roots. There would be a number right here normally with other kinds of roots, cube roots, fourth roots, fifth roots, stuff like that. But in this case, it's implied that there's a 2. The second root of 81, of course, equals 9. So what's another way to rewrite 125 to the power of 1/3? 3 is the bottom number. What kind of root are we going to do? A cube root. C-U-B-E root. Cube root. So this is the cube root of 125. You were given a resource long time ago with the red list numbers. It had square roots, cube roots, all that. So you don't have to get it out right now if you don't want to, but having that handy will, I think, be beneficial for you. Okay, let's take a look at another one. What would be another way to write 32 to the 1/5? Thank you. Appreciate you. Muchas gracias. What does the 5 imply? Say again, I can't hear you. It's going to be a fifth root of 32. Very good. And if you had that sheet out, which again, you don't need it right now, but the fifth root of 32 is 2. The implication being that if you raise 2, of course, to the fifth power, you probably have that one memorized. 2 to the fifth power equals 32. Okay. And we can even combine these concepts. There's multiple concepts. I could combine them into one. So if I had like 125 to the 2/3, I can tell you that the answer to that is 25. And honestly, being able to do this math isn't really going to be a monster issue today, but I still think it's okay just to kind of meander our way across the bridge while we're here. So first off, let's talk about the bottom of the fraction. You've already seen this once today. What does the 3 imply? A cube root. So we're going to take the cube root of 125, which we already know from an earlier example is 5, right? So then how would I say then that the answer is 25? Well, let's take a look at this little man here. See the 2? He says, watch what I do. I'm going to take your answer and raise it to the power of 2. So the fractional exponent has 2 parts to it. The bottom part is the flavor of the root that you're going to take. And the top part, mostly what you're going to, I think exclusively today, you're probably going to see 1s. But when the top number is something other than a 1, then you simply take the root that you get and raise it up to that power. Got it? Let's try another one just to see, and then we'll move on to what we're actually doing here today. So how about let's do 81 to the 3/2. I still only hear a couple of voices. I assume you all know by now, 5 minutes into this, but let's just make sure we're clear. What does the 2 say? It says take a second root, which we know as a square root. A second root is called a square root. We're going to take the square root of 81. And then what is this little fella up on top going to do? He's going to cube the answer. Very good. So I'm trying to color code this for your convenience. Okay, so the red number on the bottom of the fraction is going to be the kind of root that you take. The yellow number on the top is going to be the exponent that you apply generally after the fact. And you can apply the exponent early or late. I'll talk about that kind of as we go through the lesson here today. All right. So what's the answer to this one? Let's start with the square root of 81. What is that? 9. Anyone remember 9 to the third? 729 is correct. So the answer to this problem, 81 to the power of 3 over 2 would be 729. Okay. So I just want to kind of get that basic stuff out of the way. Next thing I want to show you is some various ways to rewrite some stuff. And so we're going to go backwards now, essentially. We're going to do the cube root of 81. This is where it'll start to get a little bit tricky. You're going to find parts of today's lesson where we take jumps and, you'll kind of walk along really nice and logically, and then we take big leaps. This is one of those big leaps. So what we want to master today is the art of rewriting things for reasons, again, that you'll see once I get to the back page of the first note card. So if I have 81 to the third power, I'm going to write it like this, and I'm going to see if you can buy it. If you think I'm full of hullabaloo. Your ability to do this is what will determine whether or not you survive the next few days of this class. So let's talk about that. I changed 81 into the cube root of 81. I changed into 9 to the 2/3 power. Let's talk about that fractional exponent. All right. Where did the 3 come from? You're still not answering that question. I maybe just need to go home for the day and take the day off. Where did this 3 come from? Thank you. The cube root, right? So if it's a third root, the bottom of my fractional exponent is going to be a 3. And where did this 2 come from? Would you guys all agree? Watch my pen here real quick. I'm going to do something. I'm going to erase this. Would you guys all agree that am I within my rights to replace 81 with 9 squared? And then you can see the construction of this happening. You can see that the 2 flies to the top of the fraction. And like I said, I alluded to this a minute ago, that power doesn't have to be an afterthought. It doesn't have to be outside. It can be inside. So that's why I'm within my rights to say that that could be rewritten as 9 to the 2/3 power. Here's another one for you. Can anyone think of a different way to write 81? I'm going to erase again. Can anyone think of a different way to write 81 other than 9 squared? It's on your times exponent sheet. 3 to the 4th power. So again, if I can just replace 81 with the number 3 to the 4th, what's another way to write the cube root of 81? Take this expression right here and let's rewrite it. What would that say? 3 to the power of what? There you go. Now I'm getting some answers. Good. And again, the things just say, they high five and say break, and then they each go to their individual locations. The power on the 3, 4 says I'll go to the top. The index or flavor of the root says I'll go to the bottom. We got this covered. Lockdown. Let's practice this skill again, because again, we just can't do what we need to do if we're not good at this. Let's do the 6th root of 16. This one also has 2 various answers or 2 different answers. What we're thinking here is let's rewrite the number 16. Give me one way to rewrite 16. Using exponents, of course. Thank you. So I could rewrite 16 as 4 squared. So if I take out the 16 and I write it as 4 to the 2th, like this. Perfectly legal, right? What would be the rewritten form of this? 4 to the 2/6. Very good. Okay. And I know I said 2/6, but of course, we're in big kid school, so I reduced it to 1/3. Got it. Let's go back in time and let's rewrite 16 again. What's another way to write 16? 16 can be written using exponentiation two different ways. 16 can be 4 to the power of 2, or what else could it be? It could be 2 to the power of 4. And you'll see, why are we doing it multiple ways? Because as we get into this, you're going to see that I need to be able to be flexible. I might want to write an 81 as a 9 squared. I might want to write it as a 3 to the 4th, right? A 256, I might want it to be 16 squared. I might want it to be 4 to the 4th. Like each situation is going to be different based on the base of our logarithms that we're going to see. So if I replace this with 2 to the 4th, perfectly legal, what would that be? 2 to the power of what? Good job. Thank you for reducing it that time. 4/6 reduces to 2/3. Okay, let's practice again. The 4th root of 729. You should see 729 twice on your sheet. The one that you probably have memorized by now, the most obvious one, is 9 cubed. So let's start with that one first. Those two expressions, numbers, should be interchangeable to you by now. 9 cubed, 729. It's like 2 plus 2 and 4. Same thing, right? What would this one be if I wrote it using exponents? 9 to the what? 3/4. Good. What's another way to write 729? Good job. Thank you. So what this also is the 4th root of 3 to the power of 6. And what would that one be written as using exponentiation? 3 to the 6/4, which, bless your heart, you reduce to 3/2. Okay. You comfortable with that process? These numbers are like chameleons, and we can they morph, and we help them morph based on our selfish needs. If we want something to be a 3 and it says 27, we're like, oh, you're 3 to the 3rd. If something says, 100, but we want it to be a 10, we're like, oh, you're 10 squared, right? If it says 32 and we want it to be a 2, we say, oh, we'll call you 2 to the 5th. We make the bottom whatever we want it to be based on our needs. And before I flip this note card over, just FYI, this also works when things are on the bottoms of fractions. And so let's say we had 1 over the 5th root of 125. The key here to getting through this is just be patient. Let's start with the 125. There is only one way to write 125 using exponents. What is it? It's only one. He's 5 cubed. That is all he is. He's pretty boring. Some numbers can go a lot of different ways. 125 is like, sorry, man, all I can offer you is this. So I'm going to rewrite this problem as 1 over the 5th root of 5 cubed. See it? So the question becomes, how can I write this as a power of 5? 5 to the what? It's not 3/5. I know your heart is in the right place. And the fact that you just said 3/5 tells me you are listening and you're learning. And I agree that the yellow number, duh, is the 3. It goes on the top of the fraction. And the 5, duh, is the bottom of the fraction. So why is my crackhead teacher telling me that it's not 3/5? Where is the radical? Where is the root? Where is this occurring? In the bottom of a fraction. And how do we know? What do we have to do to make things go to the bottom of a fraction? What kind of exponents do we give things to make them go to the bottom of a fraction? Negative exponents. So the answer, bless your heart, you were really close, is -3/5. If we need the exponentiation to occur in the bottom of the fraction, we need to give it a negative exponent, not a positive. Let's try it again. Let's try 1 over the 4th root of 8. The number 8 can only be written one way. What is it? 2 to the third power is the only way to use exponents to write 8. He is 2 times 2 times 2. And you see it there. What would this be? If I said I demand that you write it as a power of 2, what would it be? Negative 3/4. Nice job. Good so far? All right. So having said that, now we need to talk about logarithms. And so in order to get through this, I need to express to you that what our goal here is, well, I don't know. Let me see if I can. I don't know. This is always such an easy conversation that I, in my special way, find a way to make it hard. The answer to this is what I call a redundant log. If you think about what a stupid question this is, what I'm asking you for is the number that's going to go in this blank is going to be the power of 4. Right? Remember your water cycle from yesterday? 4 to what power equals 4 to the third? Well, I think it's 3, right? And the reason I can get away with this simplicity is because of the redundancy of this. Look, the base and the base are the same, right? Simple pimple. Having said that, let's do another one. Let's do log base 17 of 17 to the 19th power. What's the answer? 19. Let's go again. Too slow. Log base 11 of 11 to the 41st power. What's the answer? 41. Good. Let's go again. Log base happy face of happy face to the 112th power. What's the answer? 112. These are redundant statements. They're stupidly simple because I'm literally asking you for what exponent is needed to make it look like this. It's like, are you tricking me? I'm not trying to, but something about this. So our goal for the next little while is going to be to create redundant logs. We're going to take logs that are not like this and we're going to make them like this. Okay? So I present to you this. This will be the first time in the last 15 minutes, bless you, where you feel a little bit of closure, like, okay, a connection perhaps. Like I see now that what I just learned has some validity or it applies. What I want you to do is ignore the log for just a second, and let's make 25, the number 25, have 5 as its base. So how can I rewrite the number 25? What is 25? So I'm going to get rid of the 25, and in its place, I'm going to put 5 squared. And you can see now that the bases match, right? Help me rewrite this purple box. What does that say? I know your light just came on. This is good. Rewrite the purple box as a power of 5. What would it say? 5 to the what? 5 to the yellow, red, baby. Yellow, red, yellow, red, yellow, red all day long. Yellow, red. So it's 5 to the 2/3 power. By creating this redundant situation, I've now given you a question that is straight out an insult to your intelligence. Log base 5 of 5 to the something, the answer is the something. So the answer for the log base 5 of the cube root of 25 is 2/3. And that's brought to you, made possible by being able to convert those radical expressions into exponential expressions. Let's go again. Now we're cooking. Log base 6 of the 8th root of 216. Ready, go. What do I want 216 to be? I want him to be a 6 to the something. I want him to match the dude at the bottom. That 6, the base of your logarithm is saying, if we're going to make this easy on ourselves and not have to use a calculator, then you better be able to write 216 as a power of me. And I'm like, well, it just so happens I've got a set of skills. What is 216? It is 6 to the third. So then, and you don't have to keep rewriting it like I'm about to do, but it helps early on for you to see that what this is now is log base 6 of 6 to the power of 3/8. What then is the answer? Obviously, it's 3/8. We put ourselves in an advantageous situation. So this is the first time you get to make a choice. I haven't given you any choices in the last two. I was pretty bossy about this. Like 25 can only be 5 squared. 216 can only be 6 to the third, FYI. This one, you're going to have a choice. And let's talk intelligently about what the right choice is. Let's do log base 3 of the fifth root of 81. The trouble for me is this. 81, I have a decision to make. For the first time today, I could think of 81 as 9 squared, or I can think of him as 3 to the fourth. Which one do I want? I want 3 to the fourth because I want to pick the one where the base will match the base. So I'm going to take the 81 and I'm going to rewrite it as 3 to the fourth. Follow? And let's see if we can do this one without rewriting it. What would the answer be? Can you see it already? 4/5. Done. Let's go again. Log base 11 of the square root of 11. This is one where I don't really need to do any fancy exponentiation. What I need to do is I need to understand what this purple box means. And this is what I started class with today, 20 minutes ago, was this question. Bat. What's another way to write the square root of 11? Yes. So what this problem really says is log base 11 of 11 to the power of 1/2. By creating that redundancy, again, the answer just falls right into your lap. It just falls right onto your paper. What is the answer? 1/2. The goal here for the day, the hot topic and theme for the next couple days is, can I make my bases match? Because if I can, then the answer will just fall right out. Let's go again. Log base 8 of the sixth root of 32,768.
Oh, yeah.
So this would be a good time for you to have that sheet out, the power table from yesterday. What is 32,768? I mean, it's probably some other, I could write it a lot of different ways, but what's the only one that I care about? It is. I want to know, and you'll see in the directions, I'm going to tell you straight up, no calculators. And I'll let the sub tomorrow know too. This assignment is a no calculator, no Chromebook assignment. Everything you need is on that power table, okay? No technology for this at all. So I look on my table and I say, I wonder if there's a power of 8. 8, you see, 8. And I go, yeah, there is. 32,768 is just another way to say 8 to the power of 5. And look at the redundancy we've created. We've got a base of 8 matching a base of 8. What's the answer? 5, 6. Let's go again. Log base 7 of the fourth root of 5,764,801. So we got our table, our power table out, and we immediately, like eagle hawk eyes, go right to the column of sevens, right? Do you see a power of 7 that equals that? 7 to the 8th power. So I just rewrite this very simply without any technological assistance as log base 7 of the fourth root of 7 to the power of 8. And there's the redundancy. If you don't know what I'm talking about, just look. This and this are the same. Therefore, my answer is simply going to be the ratio of yellow over red. What is 8 over 4? The answer to this was 2 from the beginning. And then the final press before I change note cards again is, can I do this when the stuff is on the bottom? And the answer is yes. Putting things as your teacher, when I put things on the bottoms of fractions, I'm really not doing anything that massive. All I'm simply doing is forcing you to understand that you need to use negative exponents. That's all. So let's start by talking about our guy, our target, number 64. What is 64? He's several different things, by the way. He is 8 squared. Am I interested? No, because that base is not an 8, it's a 4. He's also 2 to the 6th power. Am I interested? No. Which one am I interested in? He's 4 cubed. So again, I have my pick, but I'm not going to just pick willy-nilly. I'm going to choose to make 64 into 4 to the 3rd so that this green number is the same as this green number. That's the goal. Matchy match. What's the answer to log base 4 of 1 over the cube root of 64? It is negative 3/7 all day long. Nice job. So far, so okay. Where are we at? Scale of 1 to 10. 1, I'm out of here. I'm done. I'm dropping this class. 10 is like, it's good. I'm good. You're 10? Feel good? All right. So this is where I think we're going to take a little bit of a turn for the difficult. I have 2 sides of a note card to go, but this does mark the final push. And the issue that you're going to face here is when we play the base matching game, it isn't going to work. And I'll show you what I mean. I'm going to write in a different color over here. So I just want to show you, if I gave you log base 8 of 512, I could play the matchy game and I could just write 512 as 8 to the 3rd and I'd know the answer is 3. The trouble with this is I cannot turn 16 into a power of 8, right? You agree? Like 8 to the 1th is 8. 8 to the 2th is 64. 16 just gets jumped right by. There's a fix. And I've got this down to a science, but I need you to follow directions. I circled on the worksheet today or tomorrow that you're going to get. I circled when this happens. You'll see when you get the paper tomorrow, problem 14 has a circle around it. And I put that there as like a point of interest to say, this is where you have to start doing this. Ready? Step 1. This works. Ready? Make it an equation. Started using this method few years ago, and I was like, man, why did I not always do this? Man, this is money in the bank. So what we're going to do is whenever the bases aren't matchable, we're going to set the whole thing equal to X. Seems weird, I know, but then we're going to employ the water cycle. We're going to just do what we do. We're going to say this to the power of this equals this. We're going to write that down. We're going to say 8 to the power of X equals 16. And you see the quandary right away. You're like, well, this is witchcraft. 8 has no power that equals 16. Of course it does. It's just not a whole number. Now we're going to play base matchy. What are 8 and 16 both powers of? Yeah. Yes. 8 can be written as 2 to the 3rd. 16 can be written as 2 to the 4th, right? What I'm going to do is I'm going to use some basic properties of exponents, and I'm going to call the left side 2 to the power of 3x, because those have to multiply together. And it is a fact. If you're still with me, this is not even math. This is common sense. If I have 2 to some power, and I have another 2 to some other power, and then I tell you, you ready for this, that they're equal, what has to be true about the powers? What's the only way for this to be true? They got to be the same. So you're telling me that whatever 3x is has to equal 4? Yes. And if 3x equals 4, bust out your 7th grade math skills, divide both sides by 3. What does x equal? The answer to the problem was 4/3. Notice I did not write x equals. This is not an equation. We made it an equation. X is not a real thing in this problem. He was a helper. Do not write x equals. He's there to help us, but then we got to drop him at the end. That's why we couldn't find x, because it wasn't a whole number. That's a tough one. Let's go again. Round 2. of a lot of rounds to go. Here we go. Log base 27 of 243. Again, 243 is not a power of 27. So we know we're not going to get a whole number for our answer, right? What are 27 and 243 both powers of? 3. So let's get ahead. I got ahead of myself. Let's put our equals x over here. And then let's water cycle it out. We're going to have 27 to the power of x equals 243. Now, what we're going to do is we're going to take the 27 and we're going to write it as 3 to the what power? So the left side is 3 to the 3x. What is 243 as a power of 3? And again, playing base matchy game, I employ some relatively low-level logic and say, well, gosh, if 3 to the boo equals 3 to the b, then boo has to equal b, right? No way around the fact that whatever 3x is, it has to equal 5. What's x? The answer is 5/3. Again, not x, just 5/3. Let's go again. Log base 125 of 3,125. If the problems made it onto this note card, it's because they're not immediately evaluatable using whole numbers or integers. What do we do first? Stick an x in there, equals x, water cycle it out. 125 to the power of x equals 3,125. What's that take? 5 seconds? Do it every time. When the bases don't match and they're not matchable, equals x, water cycle it out. What are 125 and 3,125 both powers of? What is 125? So this side is 5 to the 3x. What is 3,125? 5 to the 5th. So you're telling me that 3x must equal 5? Correct. What's x? Done. Hate to say it, but do you think this works with negative exponents? Of course it does, right? So let's practice our newfound awesome skills on one that requires a negative exponent. Let's do log base 81 of 1 over 729. Right away, equals x. Cycle it out. 81 to the power of x equals 1 over 729. For the 28th time today, and the 28th time out of 412 to go, what are 81 and 729 both powers of? 9. They could also both be powers of 3, but you're going to get more bang for the buck if you pick the higher common power, right? So we want to choose the 9 and not the 3. So we're going to call the left side 9 to the 2 x, right? What's the right side going to be? It's 9 to the what? No. Yes. Has to be a negative since it's on the bottom, right? It's really not that different. So then what I take out of this is, well, if 9 to you is the same as 9 to that guy, then those two guys have to equal each other. Therefore, 2x must equal -3. What's x? Therefore, the exponent, the answer, the logarithm, whatever you want to call it, is equivalent to that. That good? Log base 16 of 60. Oh, start out equals x. Hit it with the water cycle. 16 to the power of x equals 64. And now we play the matchy game. What are 16 and 64 both powers of? 4. I noticed you didn't say 2. Why not? Because it's smaller and 4 is better. Bless you. Okay, so 4 is going to be our best bang for the buck here. So I'm going to take this number 16 and I'm going to write it as 4 to the power of 2. And then I'm going to apply the x and make it 2x. On the right side, what is 64? 4 to the power of 3. Now that we're on like chapter 9 of this book, are you feeling it? You seeing what we're doing here? Playing the game of matchy base. So then 2x must equal 3. What does x equal? Correct. And remember, do not write x equals. We are not solving equations. We are evaluating logarithms. We're creating little equations as a side project that's going to help us, but that's our business. Okay. The math gods would frown upon that. Let's go again. Log base 512 of 64. Bless you. This first part, if someone says, I don't know what to do, I mean, that's where I kind of am not very patient with this. It's like you start by doing this, and then you start by doing this. And how much math have I done to get to here? Exactly 0. Nothing. Okay, I put in equals x, and then I just hit it with the water cycle. And that water cycle, again, is bottom dude to the power of this dude equals this dude, right? What are 512 and 64 both powers of? 8. So I'm going to take the number 512 and I'm going to rewrite it as 8 to the what? Yep. What is 64 as a power of 8? 8 to the tooth. Boom. Matchy game over. Victory. 8 is the same as 8. Therefore, exponent, you must be the same as other exponent. X equals 2/3. One more, and then I'm flipping the note card over for the last time. Got it? Let's go with log base 16 of 1 over 32. Right away. What do you know about the answer? Go. It's going to be a negative. Has to be. So let's start by just following directions. Set it equal to x, cycle it out. 16 to the power of x equals 1 over 32. Great. Now, we can never avoid this conversation because 16 is not a base that is powerable to make 32 using whole numbers. So I got to play matchy game. What are 16 and 32 both powers of? 2. I know, and you know, and if you haven't memorized stuff yet, you're going to just because you won't have a choice. Like you're just going to eventually get so annoyed with being slow that you're going to want to start memorizing facts, like the fact that 2 to the 4th is 16. What is 32? What is 1 over 32 as a power of 2? 2 to the negative 5th. And again, matchy game complete. If base e equals base e, then exponent must equal exponent, meaning whatever 4x is, it has to equal -5. What's my guy? Done. And on to the last part of this. Only got 6 minutes. Might be a tall ask, but I'm going for it. Ready? If you've survived all this and still feel good, I am not going to confuse you now because this is just a logical final sort of step in the process. So we're going to do log base 9 of the 5th root of 27. You might look at this and say, well, this looks just like what we did 15 minutes ago. And yeah, I get it. I get it. Well, what's different now is that the base 9 cannot be written with a whole number exponent to equal 27. That's why it's on the 4th side of the note cards and not the 2nd. So we're going to play matchy game, but we're going to start by writing equals x. And then we're going to hit the water cycle. And we're going to say 9 to the power of x equals something. I am not going to write the 5th root of 27. I'm going to sit here and sip my coffee for however long it takes until someone can give me a better way to write this purple box. No. I'm going to sip. I'll give you a hint. What's the exponent? Oh, that's my boy. And now it's no different than the problems that came before it. Okay, I quick made a conversion. I took that radical expression and I turned it into an exponential expression. And now we are money. These are going to be a little tougher, a little more basic math at the end, but we got this. Lock in. What are 9 and 27 both powers of? Correct. So this 9 right here, I'm going to rewrite as 3 squared and then stick the x on there. And then this 27, I'm going to write as what? 3 to the third, except I'm going to multiply by the 1/5 and call it 3/5. You all agree, you've known this since like little kiddie school, that 3 times 1/5 is, 3 over 1 times 1 over 5. So it's 3 over 5, right? We did it. Matchy base done. 3 is the same as 3. Redundancy in place. You're telling me that whatever 2x is, it has to equal 3/5. Correct, Amundo. Channel your inner seventh grader when I ask you this question. Are you ready? How do you solve that equation on the board? Well, it didn't go as well as I thought it would. Divide by 2. We're going to divide both sides by 2, which means that x is going to equal 3 over twice as much as 5, which is 10. When you divide a fraction by 2, just make the bottom twice as big. Was that gnarly? Let's go again. Log base 81 of the 5th root of 729. I've asked you this exact same question before today. Actually, I'm not ready for the question yet. I got a little ahead of myself again. I got to put my equals x and cycle it out. 81 to the power of x equals what? Yeah, boy. And now it's time to play matchy base. Matchy base, matchy base. What are 81 and 729 both powers of? 9 for the win. So this 81 I'm going to write as 9 to the power of 2. I'm going to stick the x on there. And then the right side, I'm going to take the 729 and write it as 9 to the power of 3. But I'm going to blend the 3 with the 1/5 and call it 3/5. Matchy base complete. Redundancy in place. A fact. 2x must equal 3/5. What does x equal? Did I just give you 2 problems with the same answer in a row? Holy nutso! That's cray cray. That's craycology. Let's go again. Log base 8 of 1 over the cube root of 32. What do we do first? Equals x. And then hit it with the old water cycle, right? That's going to say 8 to the power of x equals 32. 32 to what power? What did you say? No, say it again. I don't know. You whisper at me and I can't hear you. I don't know why you guys whisper at me. What? I don't know. You don't know. Yes. I just honestly could not hear you whisper at me, and I don't know why you think I should be able to hear you. You guys creep me out. It's negative because it's on the bottom, and it's a 1/3 because it's a cube root, and now we have to play matchy base. 8 and 32 are both powers of 2. What is this 8 as a power of 2? So 2 to the 3x. What is 32 as a power of 2? 2 to the 5th, so this is negative 5/3. Done. It immediately goes from an 11th grade math problem to an 8th grade math problem because now there's no more talk about exponents and logs and all that stuff. I can just simply say, oh, so you're telling me that 3x has to equal negative 5/3? Correct, Amundo. And how do we solve that equation? Divide by 3, which in other words means to just make the bottom 3 times as big. I came up about 8 problems short. That I skipped 1 or 2 problems on every side of the note card, but I'm going to consider this mission pretty much complete. And tomorrow, I believe it's Mrs. Thomas will be your sub, I'm pretty sure. And she will give you assignment number 36, and you will work on that for the duration. Got it? All right.
Say more.